All right, how's everybody doing tonight? Let's go ahead and get started. We are in week 3, believe it or not. I have everything graded up to week 2 as of yesterday. So if you did turn something in today, I don't have it graded as yet, up through week 2 anyway. And so this week you've got chapter 2 review question quiz, and then also the review questions for chapter 2. And then tonight we have a lab, which is just going to be basically a video we're going to watch on data packets. You can go ahead, if you're already in Eagle, and submit your first and last name in that week 3 lab, so you can get the points for being here since you're not really turning anything in tonight. Yes? Nope, no, I think you guys, I did it manually for you last week. Everybody had full credit last week. Oh, red just means it's been passed. You should have gotten a score though, correct?
Right, but it's in the milestones that we haven't completed.
Yeah, don't worry about it. Yep, don't worry about it. It'll be red forever, right? All right. A couple of things resources I want to show you real quick. One is Entree, I found out, is not doing the dinner and learn anymore, but there is a couple other opportunities for networking students. One would be the IEEE.org, IEEE.org. It's a free resource for students to sign up, and they do have events around the Rockford, Chicago area. They have a student chapter, but it basically allows you to get free resources, training. There's student competitions. They have like networking competitions, programming competitions, video, a whole bunch of neat stuff. They have student scholarships, IEEE magazine you'll get when you sign up, student member benefits. You get Microsoft software when you're part of the IEEE organization. Student member dues for this part of the software part is $32, one-time thing, I think. And basically on this one you get like an MSDN type of license for all new OSs and software coming out through Microsoft for $32. It's pretty good. If you've ever purchased an MSDN license at a workplace, it's into the thousands. So it's pretty reasonable for $32 to get that. It also has National Instruments is offering IEEE student and graduate members in the U.S. and Canada. They have what's called a LabVIEW, which is a project-based learning module, which a lot of schools actually use. And some schools actually pay up to $10,000 for the module that you get for like $40 or something like that. So a lot of good deals. It also has on the site upcoming events that are coming up. It does have local IEEE student communities you can look at, locations of where we're at, and see if they're what the chapters are here locally in this area. And second site I wanted to show you was, I talked about this last week, was logmein.com. If you do have a computer at home at work that you want to log into, you can use this service at no cost. I've used it for about 8 years. I don't get paid to tell you about this, but it works on all mobile devices, iPhone, Droids, also uses on Mac or PC devices. And basically you have up to 5 computers you can connect to. I'll go and show you what it looks like to connect into. Like I've got my work computer in the day, I've got my Mac at home, my MacBook Pro here I'm on, and then the MacBook here is actually online. So if I click on the one at work and log in, gives you a regular login prompt like you would if you were sitting in front of it at work. And then you can remote control into that device, into that operating system. And now you're actually viewing, I'm viewing the computer at my day job as I'm sitting right in front of it. Go in there and begin working, programming, whatever it is that I'm doing. So I definitely recommend that. It does have an option in here. It's kind of nice, and if you have this connected to a server, it has an option in here in preferences. Go back to I have it set on mine. On preferences, it has what's called a screen recording option that basically you can record anytime you're going into your session remotely. It'll record a local AVI recording of what you've just done up to, I have it deleting when it reaches above 5,000 megabytes of data, which is a lot of video. You can go back. And then, so that's nice because you can actually be doing something on your computer, and every time you remote in, it's recording it. So if you wanted to go back and watch those steps later, you can do that. Or the way it is used in some locations that buy this as a corporate type of entity, when people are logging into the same server all the time, multiple admins, it'll actually record every admin's instance of logging into that server and what they've done. And you can have the file going to a location that may be secured to a system admin type person to be able to get to. It also has some cool options in here like wake on LAN from sleep mode and power off. And you can actually set in here it says here, wake on LAN from power off state is only possible when wake on LAN is enabled in the BIOS, which a lot of your PCs have enabled on a NIC card. So it'll actually wake it up when you log in. Say you try to log into logmein.com, your computer's actually shut down. If you have wake on LAN turned on in BIOS, it'll actually start up that PC to where you can log into it.
Power could be off.
Power could be off, correct. Yep. The other one it has that's kind of nice is this reboot options. Allows you to go in, and if you wanted to do a forced reboot, you could do that like an emergency reboot. You can schedule reboots periodically if you wanted to. And then, so I definitely recommend it. It's really a great tool, totally free. And I've used this one I've used it since it came out. I believe it's about 8 years I've used it now, 8 or 9 years, something like that. So it's a great resource. Definitely recommend it. And again, logmein.com. Up to 5 computers can be logged into it.
Do they make money on that?
Yeah, they have a pro version. They have a pro version, which a lot of companies buy into. Network consultants.
So after you play with it for a while,
Oh yeah, like if I was a consultant and I had a lot of clients, it's really reasonable because you can buy a pro package for like, $200-300 a year and get as many computers as you want to on it. So it's really reasonable. And so, but for average Joes like you and I that use it just for workplaces that have 4 or 5 computers, it's perfect. If you have a lot of servers and a lot of clients, you can definitely go to the pro version. So it's really nice, definitely. So that's how they make their money. They make the money off the pro version. And for people like me who tell people about it all the time, I've actually had a lot of businesses buy this for their business to use for, 40, 50, 60 computers because it is so slick to set up and nice and easy to use. So recommend it, definitely.
you did say you could use that to log into a network and do.
Yeah, I've used it. I've used it and helped people set it up to be used to where network admins could log in to say they had, generally how they do it with network admins is they'll log into one server locally on the network, and then from that server or client, they can log into wherever else they want to. Does that make sense? So you can log into one client, and then from that client, they can remote in internally through VNC or something throughout. So, but yeah, it's been used for, multiple salespeople using it to log in. Because I think there's a corporate account one too, where you can get 100 users, 150 users type thing. It's pretty reasonable. Okay, well, let's go ahead and talk about standards of OSI tonight. We're going to look at that a little bit, discuss it, and then we got a really cool video on data packets. It's hopefully won't bore you to death. It's a good video. It's not real long. That's going to be our lab. So what we'll do tonight is, as soon as we're through discussion, we will not take a break. We'll go right into the video. It's not a real long video, and then right when we're through with the video, we're done. Okay. Next week we're going to be doing a lab on pinging, and then the week following is the cable lab. The ping lab's not going to be too long, 9-ish probably. We'll get out of here a little after 9. The cable lab, more than likely pushing 10 on that one for sure, and that's, you have 3 weeks from now for that. So, or 2 weeks from now, I guess. From now, you got the ping lab next week, and then the week after is the cable lab. So. All right, so that's what's coming up. I believe you got everybody's topic for your research paper. I have some interesting topics for your presentations for the final, which is going to be interesting. And so just to throw out some of them that you guys are going to be doing, you're going to be doing some on social networking, how that works with networking today. There's so many businesses using social media for network. There's actually appliances, and there's software you can use now on a corporate level to network into stuff like Facebook, Twitter, things of that nature. And then Wi-Fi security, some of the new technologies coming out that's not yet hit consumers. One of you is doing that. Researching on famous hackers, recent famous hackers that have hit the news the last couple of years. Those are some stuff that you guys are doing, some research topics you're hitting. And then doing it on all the way from that to general networking, Wi-Fi setup, and so it's going to be good mobile technology. A few of them doing that. So if I didn't mention yours, they're all good variety of networking topics. I think that's going to be really good. But this chapter goes over network standards, OSI models. When you take the Network Plus test, or even in Cisco, there's a section in there where you go into the OSI model, and that's what this chapter really goes over for the most part, and we'll discuss that and what it's all about. There's different layers of the OSI that we'll go over, what each functions. The term OSI is more of a philosophical terminology in networking. It's not real. It's just a way to put network into categories, if that makes sense. All right, it's a philosophy. And we'll look at how it functions. So first off, before we get into OSI model, we talk about some organizations like the IEEE I already mentioned for students. A lot of networking organizations, all of them do serve a purpose. There's networking organizations that are both in the States and then also nationally, and all of them do perform different functions. These network standard organizations have morphed over the years and changed, even since 9/11, with us going over into Iraq and into Iran. There's now a big networking consortium to set up free Wi-Fi and to homes and schools in Iraq. I had a cousin that was a part of that was in the armed forces, and so a lot of neat stuff that's happening with network standards to get the net everywhere in remote jungles of Africa, all the way to remote sand piles in Iraq. Free Wi-Fi. They're wanting free global Wi-Fi, which I think is a cool idea, actually. I think it's a pretty good idea to get communication out there. So standard basically is just a document that the group agrees on. And again, these documents that we're going to look at are documents that have morphed over the years. And you're talking about documents everywhere from wired network to wireless and everything in between. Technical specifications are precise to the market that's out right now and to the needs of a people group or a network type of technology. It stipulates the design and performance of a particular product or service. Standards are essential in the networking world. There's a wide variety of hardware and software out there. And so they try to use a standard to help design compatibility amongst all the companies developing software and even hardware to be able to talk to each other in a network. Not too long ago, there was not a lot of interoperability between networks, meaning you had a Mac network, Windows network, and Linux network that had a kind of finicky way of talking to each other when they first evolved. Not so much today. They're all pretty much talking on the same network communication, and what we call in networking is TCP/IP protocol that you'll learn more about this semester. But originally, all these different operating systems, network operating systems, function upon their own protocols. And now, because of these network standard groups, they've kind of all merged into TCP/IP protocol that everything uses now. From your desktop, laptop, mobile phones, everything uses that protocol to talk upon. So standards define minimal acceptable performance, not ideal performance, but minimal. Many organizations oversee computer industry standards, one being the IEEE, the other being ANSI, we'll look at. These are both for wireless standards and wireless protocols. Network professionals' responsibilities, familiar with groups and network standards. There's going to be a conglomerate between the professionals and those in government in some of these groups. So those that are actually in the field that are working, to those that are maybe in the more political side of it. Okay, the first is ANSI. American National Standards Institute has 1,000+ representatives from industry and governmental both. They determine standards for electronic industry and other fields. They have voluntary compliance throughout. They obtain approval, rigorous testing, and ANSI standards documents are all available online, and they're very technical. If you go to IEEE.org, they have all the technical documents out there as well. But all these are very technical documents. EIA and TIA. EIA is Electronical Industries Alliance. Some of you might be taking some electronical classes here, or you have taken some classes. This will be that organization that covers and governs that. It's a trade organization, representative from U.S. and manufacturing firms mainly. It sets standards for all of its members, help write these ANSI standards, and lobbies for favorable computer and electronic industries legislation. TIA, telecommunications industry, began in 1988, and they are EIA subgroup merged from a former United States telecommunications supplier, and focuses of this group is standards of information technology, wireless, satellite, fiber optics, and telephone equipment. And then a conglomerate group of the TIA, EIA both, guidelines for installing network cable in commercial buildings. Now the IEEE, this is one of the biggest ones, if not the biggest organization out right now, the Institute of Electrical and Electronic Engineers. Don't let the name fool you. It actually has in there not just electrical engineers, but networking folks, programmers, hardware, software guys, all in there, electronical type of devices that organizations make will be a part of this. It's international, and meaning this supersedes borders, and so you're going to find this in pretty much every known country, a group. The goal is to promote development and education, big on education. That's why the student chapter of IEEE is really good. They do give you a lot of free resources, and what you do have to pay for is pretty reasonable. They host symposiums, conferences, chapter meetings, both local, national, and international. They maintain a standards board, and they have tons of technical papers out there that govern all the technology we have, like I said, from mobile to desktop, laptop, Wi-Fi, and in between. ISO, this is an international organization for standardization, headquartered in Geneva, Switzerland. It's a collection of standard organization represented in 57 countries. The goal of these guys is to establish standards for global exchange of internetwork and internet capabilities without any barriers and free trade. Widespread authority, been around for years, and they actually do a lot of good work. ITU, International Telecommunication Union, these guys specialize actually in the United Nations, it's where they're formed out of. Regulates international telecommunications. Developing countries like Iraq and Iran, I mentioned earlier, work through this group. The armed forces works actually through this group to help install Wi-Fi and Wi-Fi Max. You might have heard of that, where it uses satellite technology for Wi-Fi. Members in this one, 191 countries, founded in 1965, joined the UN in 47. Focus of this group is global telecommunication issues and worldwide filtration of internet. They want worldwide internet capabilities. ISOC, this is the Internet Society, founded in 92, a very professional society. They established technical internet standards. The rapid internet growth that's coming, it's already here, keeping up with accessibility, security, stable internet addressing services. This is a group that actually developed the standards for IPv6. We used to have just IP version 4. Now we have IP version 6. It is the main protocol in all new computers and networks. And what that allows for is just longer, more addresses, basically, in the IP realm. Because as you can imagine, with more and more companies and even consumers getting their own domain number, their own IP number, a static IP address. Eventually, they said, before the IPv6 came out, like 2020 is what they forecasted running out of, or getting near to run out of IP addresses for companies to use. So definitely needed. Open standards on this one. ISOC does have a branch called the IAB, Internet Architecture Board. It's a technical board. They oversee the design and management. And then the IETF, Internet Engineering Task Force. They set internet system communication standards, particularly protocol operation and interaction, and anyone can submit proposals to this group. Very elaborate review, very elaborate testing, and approval processes. IP, Internet Protocol. This is basically a address identifying computers on the network, and it's relying upon centralized management authority. And you've seen IP addresses, you'll learn more about it this semester, but you have both local IP addresses, then you have external IP addresses. Local IP address ranges are made only for local IP networks, like within this room or building. External IP addresses are for external, like websites, like GoDaddy.com, Google.com. Those are external IP addresses. And one of the things you'll learn next week when we do the ping lab is when you ping, like, say, a web address like Google.com, GoDaddy.com, it brings back that external IP address I just mentioned, and then your IP addresses will actually fall into 3 separate classes, an A class, B class, and C class. There is a D class that's reserved for broadcast, but mainly A, B, and C is what you'll deal with in networks. A being local networks, local LANs, and then B and C go into the intranet or an extranet, those outside of your location that deal with external addresses. But because there's so many addresses, there's got to be some type of management of all these numbers, of all these domain numbers, all these IP numbers. There is a IANA, which is an Internet Assigned Numbers Authority. In '97, there was 3 international internet registries. The ARIN, the American Registry for Internet Numbers, the APNIC, Asia Pacific Network Internet Center, and then RIPE, the RASU IP Europeans. Now, in the 90s, since the late 90s, ICANN has now become the global of all those, kind of conglomerate into this one. It's the Internet Corporation for Assigned Names and Numbers. It's a private nonprofit corporation. It remains responsible for IP addressing and domain name management. So any IP address or any domain that a company's purchased, if you purchase one, even though you maybe purchased through GoDaddy or Network Solutions or wherever, these guys are the main grandfather over all of them. Even though these other companies can sell the domain name, these guys keep track of all of them to make sure they're available, to make sure that they even do some trafficking on, making sure it's not a terrorist type of website or stuff like that. So they work with kind of the national security as well. IANA performs system administration. Users and businesses both obtain IP addresses from an ISP, like an internet service provider. So it could be Comcast, be AT&T, to name just a couple big ones here locally. And when you sign up for your own IP address, they'll generally give you 2 or 3 static external addresses, and then you can take those addresses, plug them into your router, and tell your router, when people come to my router with this IP address, it's going to go to this server, or that server, or this server to be viewed. Okay? And so external IP addresses are popular, and ISPs are basically governed by this IANA, this ICANN group. Okay, now let's get into OSI model. It's a model for understanding developing networks. And like I said in the first class, it's a philosophical model. It's not exact. It was developed in the 80s. It divides a network into 7 layers: physical, data link, network, transport, session, presentation, and then lastly, application. It's a protocol interaction, meaning the layer directly above and below is what it interacts with. The application layer protocol interacts with software. Physical interacts with cables and connectors. So most of these terms, you can see how they kind of fit with what it does. It's theoretical and between 2 nodes. Anytime you see a diagram of the OSI, it's always between 2 computers usually talking to each other, and we'll see one here in just a second. It is made up of both hardware and software independent, meaning that it's just a model. It has nothing to do with hardware or software. Every network communication process is represented. They have what's called PDUs, protocol data units, there's a terminology to determine what layer that data is hit, whether it be, say, layer 6, 5, 4, 3, 2, or 1. It's generalized and definitely very imperfect because, again, it is just a model. So here's an example of 2 computers talking to each other on the network with the OSI model representation. Now I'll start up here on the top right, or right here. This would be the physical layer of the network. You'll notice it's all down here at the bottom. Physical layer. Physical layer deals with the medium it's traveling upon. Cat5, fiber, Wi-Fi, that would be physical. Data link layer is a protocols tied to the physical layer. So this would be like switches, routers into this area. Network is still protocols, and it could be a network address, IP address. Transport on both sides, it's basically just getting ready to package this. On the way out, it's actually packaging it on the transport to meet up with the data, the network data link and physical. On the way back, it's actually getting ready to transport all of this information back into the computer. Session, the session layer basically deals with taking the data and getting it ready for the computer or pushing it out from the computer. Presentation layer, getting it ready for the application that's going to be used. So say, for instance, you're communicating to each other, computer to computer, using an instant messenger software, okay? Or better yet, Eagle. Everybody uses that, RBC Eagle. And you're using Eagle, everybody in here is using Eagle through your web browser. That's the application, whatever application browser you use. Firefox, Safari, IE, Chrome. When it pushes it to the application, it talks to the application only on this network layer. And again, all of these are just models representing different layers broken down. And you'll note some of these layers overlap each other, and the protocols overlap each other. Like, for instance, on the network and data and transport layer, overlap network addressing, like IP address, the source IP address, destination IP address, source MAC address, destination MAC address. These all overlap a little bit. So starting out with the application layer, it's the very top layer. No software applications, but it does deal with software. Again, because anytime these explanations are for this, it always says it's not this, but that's what it's all about. It's talking to software, but it isn't actually software. Protocol functions, it facilitates communication between the software apps and the lower level networking services. Interprets application requests, like, for instance, in the instance of Eagle, sending and receiving email, maybe a chat function, maybe you're uploading a file from your local PC to Eagle when you guys submit your work each week. Those protocols are being interpreted on this level, on the application level. Okay? And it interprets that data as it's being sent. So as you're uploading a file, this layer is where it's done at in the application layer. Software applications on this layer negotiate with the application layer protocol, like formatting, procedural, security, synchronization requirements. So for instance, you have to log into Eagle, you have to authenticate, there is some security, you're not allowed to see all classes in Eagle, only those that you're allowed to see. That's all done on this layer. Presentation layer is right below the application layer. Its protocol functions are to accept the application layer data and to format it. Make it into understandable, it's understandable to different applications and to different hosts. So for instance, when you are from your local PC uploading a file to Eagle, it's going to do that through the application layer, and then in the presentation layer is where it knows what to do with it once it gets to Eagle, once it gets to the server level. You know, is it a PDF file? Is it a Word document? Is it a zip file? What is it? Example here is encoding of text. And what I just mentioned, is that text encoding a PDF file? Is that text encoding a Word document? Is that text encoding an RTF file? Is that text encoding an MP3 file, a movie file? Every file has what's called a text encoding. XML file, PHP file. And so the presentation layer here performs that coding compression needed. Another example for this one is the presentation layer services managed data and also encryption and decryption. Session layer, next one down. The third one down here. Session layer coordinates and maintains communication between the two nodes. The session connection for ongoing data between the two parties. Connection between remote client and access server. Connection between web client and web server. So connection between your client and browser and Eagle's server. That's where this layer is. Okay? When you ever had your connection timeout? That happens, right? That's where this happens, in this layer, in the session layer. It's annoying, right? But that's where this happens, is in the session layer. That's the communication, whether good or bad, that's where it happens. And that's why you hear networking terminology like, in what layer is your networking having a problem? Well, if it's in timeout, it would be a session layer. It's a session layer problem of the OSI. Yeah.
What determines the amount of time that before it actually times out?
The server.
Changing that?
Well, yeah, they do have, yes, but I don't think they have since they did this latest update. I think it's like 10 minutes right now, I think. I believe it's 10 minutes. So if you sit idle for 10 minutes, it kills out. Boom.
It's constantly timing out.
Yeah. Well, yeah, it could be. I think it's supposed to be 10 minutes, though, if I'm not mistaken. But again, since they did this latest update, I don't know. It might have bumped it down to 5 minutes. I don't have no idea. Are you guys noticing that too? Is it timing out quicker, or anybody else?
They might have changed it.
Might have changed it, maybe? Okay. And again, you know, if there's issues like that, you can always email RBC Eagle, you know, Kenny that works there, and let him know. He'd want to know for sure. And if anybody can do anything, he can do something about it. So,
Seat-based, like,
do what?
so many seats that people can log on at once?
We do have yeah, you're right. We do have a concurrent license, meaning only so many users can be logged in at one time. So that could be it, possibly. So say they have 150, I don't know, I'm just guessing. I'm just throwing a number out there. And you're 151. You might get a certain amount of time to get in, do your stuff, and get out. And if you don't get out in that certain amount of time, it times you out. I have no idea. That might be, I'm guessing be some rule like that in there. But yeah, we do have concurrent licenses, so that might be it as well. But again, that would all be done here on this layer as well, but on the session layer. It keeps the communication secure, synchronizing between the two nodes, determine if communications ended or not, and terminating that communication altogether. So even when you guys log off, it's done on that session layer. Now the transport layer, this is where it accepts the data from the session layer. It manages the data delivery. It begins to package it now to send it out. It handles flow control. It's very much connection oriented. It has in this piece where it's come from, where it's going. And not only that, but it usually has what's called a checksum to error check. And in that checksum, it will have in there the size of the data packet. And what it does in this layer is it makes sure that the size that was sent out from the source is the same size when it is received on the destination. If that doesn't match, it resends it again. That's what this layer does. That's what networking does. It'll resend it. And the video actually talks a little bit about that as well. Sometimes your packets will drop, and that's where it happens in this layer, the transport layer. And you might have even seen this happen maybe when you downloaded a file. It started downloading, and it was going pretty good, and then it maybe said like maybe at 5 minutes left, and then you look 5 minutes later, and now it has 10 minutes left, and it's starting, and almost like it backed up. It could have dropped, and then its job is to not just kill it altogether, it's to try it again, to see if until it gets that packet successfully 100%. It ensures in the checksum data integrity using this checksum, which is the size of the packet generally, and some other information about that data. Some connection and protocols in this layer. It does not establish connection with another node before transmitting data. Make no effort to ensure data is delivered free of errors. This is in the connectionless part of this, even though there's a connection and a connectionless part. This is connectionless. The one I just mentioned on the checksum is actually connection part. This is connectionless part. It's more efficient than connection-oriented protocol because it actually doesn't have any rules around it. It's useful when data must be transferred quickly. An example of this transport layer, what this is talking about, is actually in when you are uploading a file in, say, using FTP. That's a protocol you might have heard of. FTP is a protocol that web developers use to upload files to their web server. And in this protocol, this FTP protocol, once the connection's been made, you've logged in, it's fairly connectionless, but there's not much security around it. It's fairly open. But you can do things a little quicker because there's not as many rules. Then segmentation in transport layer, it breaks large data. So say you have a data file of 500 megs. This, in the transport layer, will actually take, and your network will split up that data into small chunks, bite-sized chunks, we'll say a mega piece, to be simple, and it'll upload those up one at a time, 1 meg at a time, okay? And depending on your connection speed, both locally and externally, on the other end, on the server, because you'd have great speed on your computer at home or at work, great internet speed, but really that doesn't determine how fast something's going to be uploaded or even downloaded. A lot of times it has to do with, all the time it has to do with where it's being sent. So if I'm sending a file to a server in, say, Georgia, initially when I send that file, it might actually start out very quick. And then within moments, it starts dropping down in the speed. And what it's doing is, it's looking at how large my data is, what the degradation of that data signal is I have, and then it starts dropping it down to more manageable. Yeah, it's going to reach it if I stay at this level. It's going to for sure make it the best. Might be slower, but it's going to make it. Because a lot of times if it's too fast, if I'm pushing it too fast for the server to get on the other end, the server on the other end will drop it. It'll drop that packet or many packets over and over again, and I'll just keep having to resend. But this segmentation, what it does is it does make it data more efficient, because instead of me sending a 500 meg file at once, it allows a network to split it up into bite-sized chunks to be more digestible, to push out, and to be received on the other end, basically. MTU, maximum transmission unit, is the largest data unit network will carry. The Ethernet default is 1,500 bytes. Discovery, what this means basically is on this one, around a meg, a little over a meg per data unit. That is what's going to, those chunks it's going to push out. Then what's cool about it is once it pushes it out in those chunks, it then reassembles it on the other end. So those hundreds and hundreds and hundreds of chunks that are sent out of that data, once it's split apart, are then reassembled and put back together, validated with the checksum to make sure what was sent is received in total.
The transport unit puts it all back together.
Correct. Right. On this, yeah, transport layer puts it all back together. It not only reassembles it, but it resequences them, because the way it works basically is this. You could have, just to be simple, we'll do 9. We're sending out, it breaks it up, a data packet, into 9 chunks, we'll say. Okay, bringing it across. On the other end, though, it might actually come in like this. 1, 9, 8, 7, 6, 5, so on and so forth till it comes down. It doesn't actually come in order as they're sent out. But what it does is when it does come on the other end, once it passes a checksum, it actually then re-sequences them together in the order that they were sent. So we have an example here of a message sent from one computer to the other on the transport layer. The sender sends a long message. It's split up into multiple packets, that data packet split up, goes through the network from transport to transport, and it's received on the other end. So it's sent out, repackaged and sequenced over here to where the other end can read that file successfully. This is actually just a screenshot of a transport protocol transmission, a successful transmission. A couple things I'll note, I won't read all this, but it shows the source port where it came from, the destination port here. Source port here is port 80, which is the web port, internet port. Destination port is a port it's going to on the other end, the other server that it's hitting. Sequencing number, acknowledge number, and the length is generally just acknowledgement of that signal. Again, source port here, it just breaks it down line by line on this one. It's 80, destination port, so it gives all this information here that's horizontal in a vertical format here. One of the things it also does here is it does have some flags on the transmission, okay? That's how the IP address knows, the data packet knows to be resent or not, okay? And so if, for instance, let's say congestion is happening, it'll slow it down. It'll slow down that speed. And that's generally what happens when you see a fast download that was fast start slowing down. It sees congestion. And it's not always on your end. It could be actually be on the other end. Okay, a lot of people hitting that web server at the same time. Down here at the bottom is basically the size of the packet. Now notice at the very bottom it checks to see if the checksum is correct, and it says it is correct. And the maximum segment size in this one is 1,460 bytes is what the maximum is. A little bit under what the Ethernet is, which is 1,500 and something per data packet. Network layer is the next one. This protocol, it translates a network address into the physical counterparts. It decides how to route things. This is actually the layer where switches and routers work, okay? It determines where stuff's going at the fastest route possible. Or really, maybe not the fastest, most efficient route possible. Not necessarily fastest. It has addressing in this one, and I already mentioned some of the addresses it could be. It's generally going to be an IP address of source and destination, MAC address of source and destination. A MAC address, and you'll find, we'll talk more about this, but MAC addresses on a computer network are a lot like a VIN number of a car, okay? The MAC address is unique to your computer and no one else has that MAC address. And they shouldn't have that MAC address. Now, are there such things as spoofing MAC addresses? Yes, just like there are spoofing VIN numbers for cars. There's a whole black market of that. And so types of addressing though for nodes, you've got network address, logical address. Logical address would be such things as MAC address, IP address. Network address is a network address. It's pushed out from the network operating system, and it's giving an address for that data packet. Next is a packet information. It's a transport layer. It's a logical address, and in this packet information of the transport layer, the logical address again could be the IP address of the source destination, the MAC address of source destination, and then the routing just determines from point A to point B how it's going to get there. And there's a command we do next week called traceroute that basically shows when you say type in google.com, this command shows you exactly every switch that data took to get to google.com and back. And it actually shows you the routes and the IP addresses it hit. And a lot of these switches and routers are named by location. What I mean by that is, say for instance, we're on AT&T here, and we are typing in google.com. We're going to see a lot of router names that begin with ATT-Chicago, a number, AT&T-Florida, then a number, AT&T-Indiana, then a number, and so what that's doing is it's actually hitting these large networks throughout the AT&T network to get your data from Google's server and back, basically, at the fastest and most efficient route possible. Most efficient, more than fast. Routing considerations on the network layer, as they have delivering priorities, network congestion, quality of service, cost of routes. And in the video, it really does a good job of this, but of showing you how routers work. But when a router gets your information that you're sending to somebody, it's constantly feeling out the network to know where the congestion is, where it's not, and it knows exactly where to send it to get there the most efficient and quickest route it can with that efficiency. With all the traffic going on all the time, it knows exactly where to send it. Now, do data packets get dropped and get killed in the process? Yes, but then they just get resent again by the router. The router will ask for another packet to be sent till it's complete. Next is a common network layer protocol within this network layer is the IP. The IP protocol is actually a protocol without any rules, as I mentioned earlier, and it's kind of like the Wild Wild West, but it is here in the network layer. And then fragmentation. Fragmentation is where it takes the IP address and then begins to subdivide it into smaller packets to be able to receive that data in an efficient time. So here we have, I'll just highlight a couple things here. For this network layer, let's look at the source address. There it is right there, that 140.141.147.249.7. Here's the destination address. It gives the header packet length of the data. Flags, which usually it's going to set either a 0 or 1. 1 being don't fragment, 0 mean to fragment, more fragments, do not set it. Generally the flag for fragmenting is going to be 0. Time to live, and we'll actually learn about this next week when we do our ping lab. This tells you it'll live up to 64 hops on the network, meaning it can hop 64 times to 64 different routers or switches within your network before it dies. Okay? And then TCP/IP protocol, that's the actual wrapper around IP that I talked about, the Wild Wild West protocol, IP. TCP is the transfer control protocol that puts the rules around IP. The rules that it's talking about is source IP, destination IP, file size, checksum, things of that nature around the TCP protocol does. And then it has a checksum here, which it checked here and it's correct. And again, lastly, the source IP and the destination IP. Then data link layer. This one divides the data received into distinct frames for transmission in the physical layer. A frame is basically raw data, or it's called payload, has the sender's and receiver's network address, has error checking in there, and some control information in the frame. Possible partial communication mishap is basically not all information might be received. It's corrected by the error checksum. And what happens when this happens in this layer is it's resent. That data packet's going to be resent. It does have a lot of what's called redundancy in error checking, but that's good. Redundancy in data is good. That you know it's going to get there. Possible glut of communication requests in this data link layer, meaning you will have some overload in this layer on purpose to make sure the data gets there successfully. This allows a NIC to process data without error. On the back of your NIC cards, I'm looking at all of them, they have a green and yellow light. The green light is good. If the yellow light stays solid, that's good. When the yellow light starts blinking, that's bad. Okay? Green light blinking, that's good. Yellow light blinking, that's bad. That means there's collision. And so your NIC card uses this data link layer and this flow control to give data without error, basically, to get data without error and process it without error. So two data link layer sublayers, you have what's called an LLC and a MAC. We've already talked about one. Let's talk about the top one first, the LLC, logical link control sublayer. This one actually is built into generally the NIC card portion. Most networking books don't really go into detail on this, but basically it's the controller of the MAC address. The LLC is. It's kind of like, best way to describe it, it's kind of like the computer in your car that all cars have to have today, right? I've got a 41 Chevy pickup that I bought over the summer. I found a guy that could work on it. And he was a mechanic for like 40, 45, 50 years here in Rockford, retired, had his own shop. Anyway, we were talking about, the reason I brought it up, we're talking about computers and cars. And he won't work on new cars because of computers. Because he told me, he said, what if, he goes, did you know that most new cars today, from their brake to steering to gas, is all electronic? There is no components. There is no, steel rod from your gas pedal to your carburetor, or there's no rod from your brake to the actual component that brakes your vehicle. And he said, if electronic goes out, you're dead. And I go, oh, I didn't think about that. And I pulled into my newer car when I was talking to him while he was fixing my truck. And but what he said, what was kind of interesting, is the reason I brought it up is that I asked him, I said, well, what controlled everything? What mechanically controlled everything? And he goes, the parts. And he showed me a part in one of his cars. It was like a 1950 DeSoto or something like that. Anyway, he showed me a brake cylinder. Original brake cylinder had never been replaced. Built in the 50s, never been replaced. He goes, today, all parts, regardless of what car you buy, expensive or inexpensive, usually wear out within 5 to 6 years. All major parts. That's the way they're designed. And he said, so instead of having a master controller, in the old days, what they focused on was all the individual parts and components of the vehicle were made quality, to where you literally could run them for hundreds of thousands of miles for the most part. And he goes, today everything's electronics. And he said, I said, well, you think, it's not going to change back. It's always going to get worse. He goes, yeah, I know, but, he wants more, more of the mechanical. But when it comes to networking, the reason I bring this story up is this one's never looked at much. It's logical link controller. It's kind of like the parts aren't looked at much anymore. Good parts in cars, more of, the computer parts. But the logical link controller actually takes and understands the MAC address and understands the components of the NIC card, and basically it's a good part. It doesn't ever go. This part never goes on a NIC card. It never gets fried. It never goes bad in a NIC card. Now, there are other components in a NIC card just from wear and tear that will go and will wear out, but this is a component that will not wear out. And it controls the logic of that MAC address. Now let's talk about the MAC address real quick. It's kind of a conglomerate of things, the MAC address. It's partly vendor, partly number. That's like a random number, and generally that random number is given by the vendor, created by the vendor. The 6-character number, though, is actually vendor oriented. So you have, like, say, a 3Com, an Intel, and if you look at your MAC address, and we'll do this next week when we do our ping lab, we'll do an IP config command that will show you the MAC address of your NIC card along with your IP address. In that MAC address, you'll see 3Com or Intel and then a number in there, okay? And that's unique to you, and so that's why it's, easy to talk to each other on a network because of a MAC address, because you can have conflicts, and you might have seen this on a network, where you've logged into a network device and it says, hey, somebody else has the same IP address. or you're able to click that and go on in and do your work. But how could it have a conflicting IP address? Well, it's programmed in. It's a range number that the network admin put in when he set up the network or she set up the network. And because it's a programmed range, there is capabilities of two devices having that same number since it's a dynamically designed and created number. But MAC addresses are different. It's hard-coded in to the NIC card, and there are ways you can actually even ping a MAC address if IP addresses are failing. MAC addresses frequently depict hexadecimal formats, and again, we'll get more into that next week and show you, what it looks like and all the good stuff on your computer. But here's the data link layer representing, blowing up there on the right between network and physical. You've got in this the LLC I talked about, that does not talk much in networking, but it basically provides common interface, reliability, and flow control of that MAC address. The MAC address, the reason it's talked so much about is it's actually appends the physical address of that NIC card to that device, whatever that device might be. Because it could be a desktop, a laptop, mobile, phones, everything has a MAC address. Every networkable device must have a MAC address. So all of our phones that we have now that are mobile and are data enabled, right, for network, all have the capabilities for the most part to have IP addresses and also MAC address built into the network. And so next one going on from this is the actual lovely NIC card that you'll be doing a lab in just a few weeks on this, uninstalling and installing a NIC card. And the red circle up there on the overhead is actually just showing where the MAC address is generally found. You can also use the ipconfig protocol command in MS-DOS to find that out. Now the physical layer. This is a layer that deals with transmission media. Wi-Fi, Ethernet cables, fiber, all are in this area. If you look at the back wall, you've got the red and white cables. Those would be the Cat5 cables. If you go into this case before you leave today and open it up, on the right side you'll see some fiber cables. But this protocol, this layer, accepts frames from the data link layer. It generates signals as changes in voltage at the NIC card. As a copper transmission medium, signals issued as voltage. This would be for like the Cat5. Cat would be copper. Fiber optic, light impulses through glass, plastic, to name just a couple that are made of fiber optic. And then wireless transmission. Most of you have Wi-Fi at home. This is set through electromagnetic waves. I want to talk about that for just a second because Wi-Fi transmission medium not only deals with, like, say, MAC IP address, which it does, but one of the things that also could interfere in your home network, your home environment, is with such things as, say, I don't know, maybe you have a wireless speaker system at home, or you have a garage door opener, or you have a remote whatever. This physical layer of a Wi-Fi transmission medium can conflict because Wi-Fi actually travels on certain channels on your network, and you have, say, channel 1 through, say, channel 12, and other networks in your house that you didn't know also can travel on those networks. And one of the examples would be a wireless Wi-Fi entertainment system, sound system is one. So say if your Wi-Fi is on channel 6 and your wireless speaker units on channel 6, and you wonder why it crackles every once in a while and pops and you don't understand, or your internet drops all of a sudden when you turn it on, it's because it's traveling upon the same signal. Because it is electromagnetic wave that travels on a certain level. Okay? You don't see it, but it does. And so easy fix is you're generally not going to be able to change the signal level it's on a wireless speaker system, but you can on your Wi-Fi router. You can change it from, generally out of the box, most of those are set at like 11 or 1 of those two. What I always tell students, if you ever have conflicts like that where your Wi-Fi is dropping a lot, you can actually change it to a weird number, like say a 9 or like a 3. A lot of times that works. Because most of these components that you buy, bring into your house that conflict with Wi-Fi, are usually set at either 1, 6, or 11. Those are the 3 that they're usually set at. And so if your Wi-Fi is having issues, you can set it at anything but a 1, 6, or 11 basically, and you should be okay. Now, physical layer is responsible when receiving the data. It detects and accepts the signal. Remember, this is a transmission it's traveling on, whether it be Ethernet, fiber, wireless. It passes onto the data link layer. It sets a transmission data rate. It monitors data error rates. Has no error checking in this one. Devices that operate on this one would be hubs, repeaters, routers could fall on this one. Switches could fall on this one as well. NICs operate at both the physical and the data link layer both. This is one that kind of overlaps, like I talked about earlier, between the physical and data link layer. The NIC card does. So, starting with the application, number 7, all the way down to 1. Application, providing interface between software and network, interpreting apps, requesting and requirements. Presentation, allow host and application to use a common language. It performs data formatting, encryption, and compression. Session, establishes, maintains, and terminates user connection. Transport, ensures accurate delivery of data through flow control, segmentation and reassembly, error correction and acknowledgement. Network, establishes network connections, translates network addresses into the physical counterparts, and determines routing. Data link packages data into frames appropriate to the network transmission method. And then finally,